This integral by substitution can be quite tricky, especially since it's a definite integral with boundaries from 0 to 2. So let's start. We need to show that the integral of 3x root x plus 2 dx is equal to this number over here. To integrate the left-hand side, this has to be done by u substitution, because what we have here is our composite function. Root here with x plus 2 is what we call a composite function. It is a function within a function. In u substitution, we take x plus 2 to be u. And so we will write that u is equal to x plus 2. The next step in this sort of integration is that we differentiate the u. So we find that du, and we're differentiating it with respect to x, is equal to 1. And we want just du. So we will put the dx onto the right hand side. And this is where the problem occurs, because we were hoping that du would be 3x dx. But we only got du to be equal to 1 dx. So we can exchange the dx here for du. But what are we going to do with the 3x? How are we going to change it to something with a u? Well, we can do that. And here is where what I'm looking at over here. I'm looking at this equation over here. What if I change that into u? So I'll say that x is really u minus 2. But I want 3x. Well, what about if I multiplied this x by 3? Then this will be 3u minus 6. So now I've got something to replace 3x with. So I'll use 3u minus 6 to replace the 3x. And I will use du to replace my dx. And naturally, u is going to replace this ux plus 2. So let's substitute. First of all, I substituted the 3x. I bring that's going to be u, correct? The 3u minus x should have been in brackets, otherwise it's bad algebra. And dx is going to be du. Okay, I can work with that, but I'm worried about my limits here, because I've got 0 to 2, and that was fine when I was integrating it in terms of x. I had 3x, x here and x here, but now I've changed my x to be u, and my u is x plus 2. So in that case, I'll have to change the lower limit when x is equal to 0. I will have to change it to u, which is 0 plus 2. So it'll be now 2. And when x is equal to 2 for the upper limit, this will change my u to 2 plus 2, which will make it 4. And we're working in u's now, not in x's, so I can now write that that's 2 lower limit and upper limit is 4. So I'll write down here that the limits change. Now we can integrate this integration in terms of du, but it still looks a little bit ugly. That root will need to change. I will change it to power of a half du. Okay, if I write it like this, then it's going to be very unclear. What exactly happens to the 3u minus 6? Please make sure that you write here that this is bracketed. Once you see that 3u minus 6 is in a bracket, then we know that what we can do now is multiply this by that, which means we are expanding, and this by that term. Well, this will mean that we've got a 3. Just make clear, how do you multiply u by u to the half? That means your u1 times u a half, and then it means you're adding the exponents, so that'll be u to the 3 on 2. So I have u to the 3 on 2. Now I take away and I have 6u to the half. All this is now du. So now we are going to integrate it because we can integrate it now. Now that we're integrating, we do not need the integral sign, we just use a square box. So we have 3u, we raise the 3 to 5 on 2, and we now divide it by 5 on 2. And the second part, we have 6u, raise it by 1, and we'll get 3 on 2. And now we'll divide it by 3 on 2. And we close the brackets and use the limits here. Fractions which were divided, we can now multiply them. So that will be 2 over 5 multiplied by 3 u to the 5 on 2. And the same thing will go over here. Well, 2 over 3 multiplied by 6 u 3 on 2, and the limits of 2 and 4. That 6 and that 3 cancels down to 2, so this will be just 4. So I can rewrite this again. 2 times 3, 2 times 3 is 6 over 5. So I'll write 6 on 5. Now I have a u over here, and to the 5 on 2. I will prefer to write this down as u squared root u, because it'll be easier for me to substitute those limits in. Now I do the same thing over here. 4, we just have 4, and that will be u root u. That's just me. I find it so much easier. So now when I substitute these two inside, I have 6 on 5, and I can write 4 squared root 4. It's easier to work that out. And now I have 4 times 4 root 4. That's the first part. Now I need to take it away from 2. So 6 on 5. This time I'm using 2 squared root 2 minus 4 2 root 2. Okay, that's times here. Okay, so I'll try to go faster. 4 squared is 16 times 2 is 32 minus 2 times 4 times 4 is 16 times 2, that's also 32, and 6 over 5, 4 root 2. Unfortunately I have to keep the root 2 here, and 8 root 2. I'll try one more line. That's 192, because 6 times 32 over 5 minus 32, and then better keep that in the brackets. And then we have 6 times 4 is 24 over 5 root 2 minus 8 root 2. Because I already know what the answer is supposed to be, because we're given the answer, I'm trying to manipulate it so that I'll get that answer. So I'm thinking I'm going to multiply everything by 5 over 5, and the same thing over here, 5 over 5. That means that now I'll have 192 over 5 minus 160 over 5, and that will be minus 24 root 2 over 5 minus 5 times 8 is 40 over 5 root 8. That is then 32 over 5 minus 24 root 2 over 5 plus 40 over 5 root 2 is equal to 32 over 5. Minus 24 plus 40 is therefore 16 root 2 over 5. And I'm getting somewhere. This looks a bit more like the answer that we want. Yeah, so that'll be 16 over 5 2 plus root 2, and that's the answer that they want. So this is one of the questions in the A-level exam. It's worth 7 marks. I hope that you found this useful. I have made a number of videos on integration, so please look into my channel.